Hello everyone, thank you for joining me today. My name is Minam and today we're going to be looking at stopping distances. So we only have a few learning objectives, and that's to be able to define stopping distance and to understand all the factors that affect stopping distance. So we also want to be able to recall the stopping distance equation, which is stopping distance is equal to thinking distance plus braking distance. So if you're ready, let's get right into it. Alright, so let's first have a look at my diagram right here. So you can see my stick man is just at number 1, right? He's just driving along in his car, going along the road, minding his business. Now, at number 2, you can see that my stickman now sees the sort of obstacle, right? So that would be this stickman right at the end of the road, okay? And so now this speech bubble here represents him thinking about the man, or as the stick person, right? So they've seen the stick person at the end of the road. They can tell that, oh no, I'm going to run them over. And now that's all these thoughts are running through their head. So this is where the stick person is thinking. And now at stage number 3, you can see that the stick person has now come to a dead stop, which is represented by our stop sign right here in front of the obstacle, right? So he's avoided hitting the actual obstacle itself, which would be the last stick person. So that is the stopping point. So you can see here that now our diagram is made up of 3 main components, right? Number 1, the person is just driving along. Number 2, the person's seeing the obstacle and they're thinking, oh no, I'm going to hit them. Oh no, I have to do something, stuff like that. All these thoughts are running through their head. And then number 3, where they've come to a dead stop and avoided hitting the obstacle, which would be the stick person. Now, we want to understand that stopping distance is equal to the total distance travelled from when the obstacle is seen to when the vehicle is at a stop. That's our first definition of stopping distance, right? And this is the wordy one. Okay, so all that's really doing is explaining all 3 stages of our diagram in one sentence. Now, where can I label stopping distance on my diagram? Well, that would be from when I've seen the object, so right here, to when I've stopped. So that's the distance from here to here. So this is my stopping distance. Okay, so now you can see that there are 2 main components of stopping distance: the thinking distance and the braking distance. The thinking distance is the distance traveled from when obstacle, the stick person in this case, is seen and brakes applied. Now, thinking distance is a bit of a weird concept because you think, oh yeah, if I see an obstacle, I'm going to apply the brake instantly, right? Well, actually, in reality, there is a short delay. What is that delay? Well, that delay is really made up of your reflexes, right? Because remember, humans can't do anything instantly, right? Well, if we could, that would mean we would make excellent baseball players and we'd be able to dodge bullets. We can't do either of those things. Well, a majority of us can't. But the thinking distance really talks about, oh, you've seen an obstacle, and sure, you might feel like it's instant, but there is a fraction of time that passes from you actually seeing the obstacle and then you applying the brakes. And the thinking distance is really how far you've traveled in the space of the time it took for you to see the object and press the brakes. Now, our braking distance is the distance traveled from when brakes applied and car, or rather vehicle I should say, because we're not always talking about cars, vehicle stops. Okay, so braking distance is a bit self-explanatory, but you know that when you press the brakes on the car, or if you've ever been in sort of car accident, you know that there is a moment when you press the brakes and your car sort of skids along, right? That's because your brakes aren't 100% perfect. There are forces acting on between the wheels and the road that mean that when you press the brakes, you do still travel a short distance before you come to a dead stop. Now, when we combine these 2 distances together, thinking plus braking, that gives us our stopping distance. Now what we want to look at is what sort of factors actually affect thinking distance and braking distance. Okay, now let's have a look at some of the factors influencing both thinking and braking distances. So first of all, let's look at thinking distances because that's usually the easier one. So whenever we're thinking about what affects thinking differences, think what affects reflexes, right? Think reflexes. So number 1 is distraction. So this could be phones, conversations, anything, right? If you're looking down at your phone or you're speaking to your passenger, it's going to take you much longer to see any threats and then actually react to that threat because you're distracted with your phone or your conversation. Now, number 2 is sleep. So this is really how drowsy you are. Now think about it, right? You've just woken up in the morning, right? You're getting up, you're moving quite slowly, right? If there's a suddenly, if say an obstacle suddenly jumps out in the road in front of you and you're feeling like that, it makes sense that you're going to take longer to react simply because you're moving so slow, because you're either sleep deprived or you're so drowsy, right? Next we have drugs, right? So a lot of people will just jump straight to illegal, and that makes sense, right? If you're on party drugs and you're driving, you're going to be all over the place and you can't really react easily. But it can also be legal drugs, like such as those you would take after an operation, pain medication. In fact, a lot of the time after you have been prescribed drugs like that from your doctor, you'll be asked to sign a paper that says that you won't be operating any heavy machinery, or you won't be like piloting or driving like a bus or things like that, or even just driving yourself, because these sort of legal drugs, because they dull your pain, they also dull your senses, and so you have to it takes a long time for you to perceive threats and then react to them. It increases your reaction time. Now, our last one, this is one that often people miss, is just eyesight. If it takes you longer to actually see something, it's obviously going to take you long to react to something. So that's our last factor for thinking distance. Now, let's have a look at braking distance. So this is after you've seen the threat and you've pressed the pedal for your brakes. Our first one is quality of brakes. That makes sense, right? If you have very old, worn out brakes, they're going to take much longer to actually stop your car. Next is quality of tires. Same thing. If you have old, worn out tires, they're going to drift. You're going to skid. Your braking distance is going to be even longer. Next one is road conditions. So this is, say you had a very icy day. Right? There are sheets of ice all over the road. You're going to have to drive much slower because when you press the brake, no matter how good your brakes are, there is less friction between the road and your tires. That means that you're more likely to slide, and so your braking distance will increase. Finally, we have velocity of the vehicle. So this is how fast you're going. And this is actually very, very interesting, because you'll notice that it's not a linear relationship. If you go double your speed, your braking distance doesn't double, in fact quadruples. Why is that? Let's have a look at that right now. Now, we know that the kinetic energy of the energy stored in a moving object is kinetic, right? So we can say EK, right? And the formula for kinetic energy is half mv squared. All right, so we have that. Now, when you press the brakes on your car, what are those brakes actually doing? Well, what those brakes are actually doing is doing work against your wheel. They're doing work against the kinetic energy stored in your car's wheels, because that's really where the energy is going, right? To make your car move. So if we have a look at our work equation, work is equal to force multiplied by distance. So, and the force is provided by your brake pads. Provided by brake pads. Now, we know that work is measured in joules, and energy is also measured in joules. That whenever we have two units that have the same units, we can do something called equate them. All right, we can put these two equations in together into one. So let's do that right now. So we know that work is equal to energy. So let's write down the left hand side, half mv squared, and that is equal to now force multiplied by distance. All right, so we have this. Now let's have a look at something. Our brakes can only provide X amount of force, right? There's a fixed amount of force our brakes can provide, and that makes sense, right? There is a limit to how much force that our brakes can apply. So force applied by brakes is limited, and the mass of our car is constant. You know, it's not like you start spontaneously losing mass along the road, unless of course like your door falls off or something. So mass is constant. Now, let's see if we can make a relationship. We know that a half is just an integer. That's always a half. Our mass again is constant, so we can cancel that out as well. Our force is also pretty much constant because it's limited, so we can cancel that. What are we left with? Well, we're left with velocity squared is directly proportional to distance traveled, or rather displacement. So you know what? I'm going to change the d to an s. Okay, so for displacement. So now you can see the relationship between braking distance, or rather displacement s, is directly proportional to the square of velocity. So if you're going twice as fast, you need 4 times the braking distance. If you're going 4 times as fast, you need 16 times the braking distance. Like, it really starts to jump up, which is why speed limits on the road are not at regular intervals. They're at very specific intervals to account for the fact that there is a non-linear, a sort of square relationship between the two values.